Actually, from beginning that we plan that
Oh.
have a couple of presentation from Korean side, from Dr. Choi team, and also was he now currently have a smart water project in Vietnam, in smart water project, and have on case study in Vietnam, and that's why when we have a meeting with Dr. Young, we plan to have a couple of presentation from Korean side, but it seems that today will be very busy for him, so difficult for him to have presentation. So I think we can focus on what we have done in Vietnam, and we can discuss how to link with that project later on after this.
Okay.
Okay.
So we have Dr. Jung. We have 3 speakers in our session. So
Yeah.
could you introduce the 4th speaker of our session?
Yeah. So for three speakers we have today, first is Dr. Phi. He will share one case study on we have done in Vietnam on how to use mining data mining methods, especially AI and ANN to predict the landslide in Vietnam. And the session today will focus on big data, cloud computing, and also the focus on AI, ANN, on smart water management. And so the first one maybe Dr. Phi will give a presentation on his work, and after that we have another presentation from Hướng. She have used the AI to predict the groundwater, another topic. And then finally I can briefly some of our update on our current work on related to water management and modeling and data, big data service in Vietnam and Mekong region. So you are host, so you can now the stage is for you.
Okay, Dr. Phi, can you load up your files from there?
Yeah, I think so. I can share screen. Okay, let me see.
That's good.
So it show, right?
Yeah. Now we can see your slide.
Okay, it's like that. Okay. So let me know about the time and plan if it's possible.
How about 15 minutes will be enough for you? Or if you want to spend more, maybe you can spend up to 20 minutes.
Okay, thank you. So should I start now?
Sure, please go ahead.
Okay, thank you. So, well, actually today is a little bit well, what I do is that I want to share about my research on using the data mining technique to study about the rainfall trigger, landslide, and debris flow. They are the very common hazards that very happen in the mountainous area in Vietnam. So, well, to start with my talk, I'm gonna go with the current issue that related to our weather-related hazard, and then that I focus on landslide and debris flow, and then at the final section I'm gonna demo using some data mining technique for hazard assessment. Then we all know that Vietnam is now one of the most hazard-prone area in Southeast Asia, and we have many problems with natural hazard like the typhoon, flood, landslide, drought, or seawater intrusion, and sometimes we can have the earthquake, even though it's not too big, but still we have. And in 2019, from the Global Climate Risk Index, they have a report saying that Vietnam, we are among the 6 countries that was hit by climate change in the last 20 years. And from this map, you can see that from 2004 to 2016, and then all the black dot on the map showing that that is a lot of line that landslide or debris flow that come from with the lot of line, and the line here is not only for one person, many people die, and then also the lot of line from natural hazard were reported at 2/3 of the total globally. So this based on the report from Asian Disaster and Preparedness Center. So that's why we have many problems like the landslide you should see on this photo. And when it comes, then 13 people die by in one landslide only, or even this kind of picture like the debris flow when it comes to the especially in the mountainous area, we cause a lot of trouble. And in 10 years from 2008 to 2018, the data was showing that over 200 people die because the weather-related hazard like the landslide or debris flow, and then a lot of people are missing or injured. And the number of house, this is not a round number, but it's about 40,000 houses were damaged or almost destroyed by those kind of event. And then here you see that it is a typhoon path in the last 20 years, and you can see that most of the path were coming from the what we call is the East Sea, and then also it come directly to Vietnam. Part of that went up to Taiwan, or reach to Korea or Japan also. But I can say like half of that were directly hit Vietnam on this side. So we have many problems with what we call the geological hazard, or the weather-related one, because that in Vietnam, rainfall is a main actor that cause the hazard other than the earthquake, unlike the earthquake like in Japan or in Taiwan. And flood, landslide, or debris flow were causing the human loss and also the property in Vietnam. And totally flood and landslide cause a lot of people, infrastructures, things were damaged. And this is a map that showing about the flood that hit Vietnam, and also it caused the human loss only. And this is the map I got that from the last 10 years. You can see that flood is mostly happened in the northern part of our country, in the mountainous province, and also the northern center of our country. And also for the rock avalanche and landslide, because when we call landslide here, it's I consider all type landslide, from shallow debris flow to deep sea landslide. And it also happened in the northern province and also the northern center. This is we have a very steep slope, and also it's close to the sea also. And also I have another map showing about the land subsidence. Land subsidence are the erosion is happen along the big river. We have a big river on the north as a Red River, and the south was the Mekong Delta, Mekong River. And also we have along the coastal side, the erosion were very extreme also. And so talking about the human cost, you can see that with the time from our database, it collect up to last August, showing like we have a trouble for the last about last 20 years. Over 1,000 people were die or injured because of the event, the landslide or debris flow. So the next portion, I'm gonna show you two examples from Lào Cai province and also another one from Quảng Ngãi. And these two provinces are located in the one in the north and the other in the south central. And first about the Lào Cai province, I'm take a small part. This showing this is Hanoi, the one with the red star. So it's not too far, around a few, maybe 2 or 3 to about 200 kilometers from Hanoi. And this is the main road of the area from the Lào Cai city to the nearby county. So we have a data collection from very long, quite long-term study for this area, starting from 2011. And there we collect the data from landslide, debris flow, and riverbank erosion. As you can see here, L, D, or E represented for the type of hazard. And then the fin survey were conducted in many years from 2011 to 2019. And the other data that we collected for the whole area. And I think we have over 400 data for this small area. And to work with, to prepare the database for, what can I say, for data mining approach, we need to build a lot of map as a database for them. And we separated the data into 3 categories. First one is geological condition, because that all the landslide or debris flow is happen to have some connection with the base geology. And we prepare the geological map, the lithology, structure, weathering profile, geomorphology, and even the soil profile of the area. And also for the other natural condition, actually the geology is one of the natural condition too, but I want to separate it into different category, because that the importance of that information. For the condition that related to the topography, we have the elevation, slope angle, and then terrain wetness index or the other index also. And also I have the land cover. It's from the remote sensing images, and also the human induced condition too, land yield or road or house density were all collected. And also with in the center south of our country, we have collected over 800 events, included the landslide or debris flow. And as you can see on this map, it's always happen in the mountainous area of home province. That is though are very big information for the study. And also similar to previous study, we I prepare that for the lithology, structures, weathering, and other property like geological engineering or hydrogeology map, and also the elevation, slope angle, slope exposure or drainage network or land cover, and also the human induced condition too, land yield, road, and house density. And you can see here that the people are living near the coastal side a lot. So to share about the data mining approach that I'm going to use, this is a structure of the hazard that we normally do. And today I'm going to these three comparison of these three methods, because this belong to the big data approach. So we have a good and enough the data, then we can work start working with this. And so first one about the neural network, we I think most of us here we have heard about that. It's kind of the structure showing about the input layer as a lithology or slope angle. I mean, on the map, the prepare map that I showed earlier, and the output layer gonna be like showing about the that is gonna be have landslide or debris flow or not, and this is a hidden layer, and the structure is easy to understand here. And to connect from the input to the hidden layer and then output layer, we have a transfer function. It's gonna move the information from previous node to the next node. And also this is the idea of support vector machine too. This is a 2D, two-dimension representation of the support vector machine. And then we can see that the black and the white dot can be separated in many ways. This line or that line, I mean, many ways of separation. And then the idea of support vector machine is that we are gonna find the line that have the big gap between the two. And then when we find that line, then the nearest data gonna be used for support vector machine. And then we not gonna use the point is far away from the separation line. So we call this one support vector. And to use the support vector, there are many Cagnan functions, but the most common one is the radian basis function that gonna use in this study. And also another method that we use in this study is descent tree. Descent tree is the structure similar to the inverse tree, like we're gonna see here. And what it does that it calculates the information or entropy, and then it moves from the root to the leaf later as a so this structure is easy to understand, and then all the data gonna be readable later when we finalize the tree. So to work with this study, we build the this is like the neural network, and you can see that we have around 13 input data, and then also the 7 hidden node and 1 output has that property. And then we use the sigmoid activation function, and we use 30 70 and 30 rule. It means that 70% of the data were used for training, and the last 30% of data for testing. And the stop condition for neural network is we run for around like 1,000 steps with the learning rate at 0.3 and momentum is 0.2. And this is the final map for Quang Ngai province, and this is a study area in Lao Cai province. Also, this is from support vector machine. These two map was showing, it clearly showing that Actually, later on, I forgot to put the final rate of the structure here. And this is a decent tree. Decent tree, you can see that this is the structure gonna show what is going on from the top to the bottom. So if we have time and the idea can come out from the structure of the tree itself. And this is for the decent tree. Decent tree, after we analyze, then this is a two map that showing about the probability. On stopping at this map, you can see that most of the landslide or debris flow area located in the mountainous area, and this one also, we have a problematic on the left side mountain area. This is very famous one. This is a highest mountain in Vietnam. We have a Sapa, a very how can I say, the tourist destination, in very famous tourist destination in Vietnam on the upper part. And also we have many problem on the right side mountain too, because this area are limestone area, and also alongside that road, and we have many landslide location. And comparison of those three approach in Lao Cai province is showing like the accuracy of neural network are quite high compared to the one in other method. And also for the Quang Ngai province, for data, neural network outperform the other approach. So as I get from Dr. Jung, he said that because we can concentrate on the AI, and then actually AI can use all these three approach for our study. And then from Lao Cai province, if I narrow down about the road section, we can see it clearly where we have a problematic that can come with the road section. We can concentrate on the for further study. And also the Quang Ngai province also, we can see that where the problematic can come, and we can work further for further study. So this presentation, this is kind of demonstration about the data mining technique that I'm used for two study area in Vietnam, in Quang Ngai province and Lao Cai province. And also this data mining technique, decent tree, neural network or support vector machine. Even though the success rate of the decent tree is 80 something, but still good enough for us to I become the hazard assessment tool in the futures. And all the three models were giving over 80% of accuracy, and then especially in Quang Ngai province, it shows very successful thing for method like the neural network were highly predicted for the for landslide and debris flow, and those map can be used for the further information, especially in the hazard prone area. So those are the content of my talk. Thank you for your attention.
Thank you, Dr. P. That's quite interesting research. I think your approach using that AI, artificial neural network, and data mining technology to evaluate, derive that probability for the disaster in your country. That's really hectic issue in your country. So maybe if you continue for your research with your research group, maybe you can provide much better information and knowledge to the water manager. Thank you so much. Thank you.
Thank you, sir.
Shari, because of the limited session time, Shari, move on our second speaker.
So it's Hương, right?
Yeah. Okay. So, yeah, thank you, Dr. P. Maybe we'll talk more when we finish our three speakers talk. So who will be the next speaker? Miss Hongbo?
Hương,
Okay.
Hương, can you give speak? Maybe Hương can go first.
Okay, good.
Yes, and can you give me the host? To
okay.
share the screen?
Okay, now it's yours.
Sorry, one moment.
Take your time.
Yes, so sorry, I am sharing, but
You cannot share.
yes, I'm waiting for my computer.
Take your time.
So yeah, so sorry. 1 minute.
Take
Wait for me 1 minute. Yeah.
We really appreciate because now it's midnight in Germany, so we really appreciate your contribution.
Hương.
Yeah, and can you see my screen now?
Not yet. Not yet.
So maybe Dr. Ko, can you show the screen for her? Maybe she already in your computer. I sent to you yesterday.
Yeah. And now can you see my screen?
Not yet.
Oh,
actually, you can click on share screen and for the home screen.
And now?
Yes.
Oh, okay. So sorry. And good morning, everyone. My name is Hương Vũ, and now I am a PhD student at the Technical University of Dresden, and I'm so happy today I can share my research with all of you. And today my topic is development of INN-based groundwater level forecasting model for Mekong Delta, Vietnam. And my research will including 6 parts. The first thing I will give some introduction about the study area and the reason why I choose these methods. And the second thing I will give some about some objective of my research. And the third is I will say about the methods and material to apply the INN model to predict the groundwater level. And the next part, I will give some result and conclusion and some reference. The first thing, groundwater level play a very important role in socio-economic development of Mekong River Delta. And most of groundwater now were exploited for agriculture and domestic use. However, due to the overexploitation, the groundwater level is lower day by day, and that leading a lot of consequences like landslide, drought, and soil intrusion. Therefore, it's necessary to have some predict the changing trend of water level in this area to give some appropriate warning for local people and authority. However, to predict the groundwater level is not easy because it depends on a lot of factors of nature and human. And currently, there are some traditional methods to predict groundwater level, like some hydraulics methods, the statistical probability, and trends hydrodynamics. But most of these methods has some disadvantages, like they has a high cost, and most of them require a lot of the high quality of input data, and they also cannot give the short of the predict for. I mean, this method cannot predict with the short forecasting time. And moreover, with the development of computer technology, machine learning or INN will be the new method to apply to predict for groundwater level. And now there are a lot of researchers apply this method to predict the groundwater level in some area, because INN has a lot of advantages, like they can solve the nonlinear and complex problem, and especially these methods can find the hidden relationship between the data. So I mean, INN model will be an effective tool to predict the groundwater level, especially in some area without the ground data. So in my research, I would like to apply INN model to predict the groundwater level in Mekong Delta. And with research, I have 3 objectives. The first thing, I want to determine the control and influence factor of groundwater level trending with the different periods. And the second objective is I want to evaluate the ability of INN model in the case of input data according to the space and the time factor. And the last objective is I want to forecasting the groundwater level of some wells in the one aquifer from in some area regarding the forecasting time of 1 and 3 months. And now I would like to give some general and short information about my study area. And Mekong Delta is the biggest and the most important delta of Vietnam. And this delta is well known as the rice basket of Vietnam, and including 15 provinces. And in this, Mekong Delta has 8 main aquifers from the, for example, QS, QP3, etc. And the picture about the Mekong Delta you can see on the right-hand side. And now I want to give some information about the current situation of groundwater in Mekong Delta. Because groundwater is so important for socio-economic in Mekong Delta. So at the moment, there are nearly 2 million wells, and that provide more than 2.8 million cubic meter per day for the social activity of this delta. Therefore, with the high exploitation, the groundwater in the most of province in this delta would be decreased. And in detail, groundwater level in most of the aquifer decreased from 1.1 meter to 3.9 meter compared to 10 years ago. And the Mekong Delta is a big delta, so they have a big network of stations with more than 50 hydrological stations and 28 meteorological stations, and more than 200 water resources measuring stations, including water quality and groundwater level. And here is some information about the ANN model. And because Dr. Phi also give a lot of detailed information, so I think I will keep it. And to apply the machine learning or ANN model, we have several ways. The first thing, we can apply the programming in the environment of MATLAB or Python, or we can also use some instant software. It's easy for user to apply. And here I would like to introduce about the software Win32. And this software has a good interface, and this allows the user to can check about the parameter, the graph, and the trend, the test result, and also some indicator for evaluation. And in this software have some parameter for learning of ANN. Is the eta, alpha, and input noise, or some weight noise. And in this research, I use three creators to evaluate the model results. The first thing is the coefficient of determination, and RMSE and P%. P% means the percentage of pattern with the error less than or equal the target error in this model. And in my research, I apply 5 steps to forecast the groundwater level. And the first thing, I selecting the forecast location. And after that, I need to determine which data will be the input data for the model. And the third is I need to determine the ANN network structure and parameter. And after that, I can training and testing this ANN network with the input data. And after I can get the good ANN network, I can forecasting the groundwater level with this model. And in my research, I apply this ANN model to predict the groundwater level for one aquifer named Middle Pliocene aquifer. And this aquifer divide in 3 regime area, including natural regime area, tidal regime area, and destruction regime area. And in each area, I choose one well to predict. For example, in the natural regime area, I selecting the well number Q04004M1 in Dong Nai province to predict the water level. And to predict the groundwater level for this well, I selecting the data about the rainfall, the groundwater level, and the tidewater level, and also about the exploitation discharge amount in some station and some well surrounding the well I want to forecast. And the data I apply is the monthly data from 1996 to 2010. And I divide this data set into 3 parts. The one part for training, one part for testing, and one part for forecasting. And you can see detail about the data pairs I apply for each cases. And in my research, I use ANN model to predict groundwater level with the forecasting time before 1 and 3 months. And to prevent from overfitting for ANN model, I apply the stepwise algorithm in SPS software to select the elements that have the high effect on the output data, and the yield data to analyze is the previous data from 1 to 12 months, comparing to the forecasting time of the output data. And here in the table, the elevation have the high effect on the output data after I apply the stepwise algorithm to analyze. And now I want to give some more detail about the result for forecasting what the groundwater level for one well I talked before. And in these cases, I give some result for forecasting time of before 1 month. And here I show about the model structure for training, testing, and forecasting with the same structure, including 17 input data and 12 hidden layer and 1 output data. And most of the result has the good result with more than 90%. 90% of pattern have the error less than the target error, and the average errors less than 8 centimeters. It means I can get the good result, and ANN can predict the water level nearly. ANN can predict the good result for groundwater level. And also the same with the cases of forecasting time before 3 months. And I apply another model structure with the 14 input data and 10 hidden data and 1 output data. And also in these cases, I also get the good result with more than 90% of training of testing, and the average error is less than 4 centimeters. And with the same method, I give some result for another dynamic zone for tidal regime area and destruction regime area. And in each cases, I use another structural model, and also most of the cases get the good result also. You can see on the table for more detail. And now after applying my research, I have some conclusions. The first thing, ANN with the backpropagation algorithm is an effective tool to forecasting the groundwater level. And the input data we need to select carefully by evaluating the correlation between the factor and predicting element. And in my cases, the impact of groundwater exploitation is not shown in by ANN model because before applying, I choose a stepwise algorithm to analyze this, to choose the element has the high impact on the output data, and I saw that the groundwater exploitation element don't have any relationship with the output data, so I cannot put in the model. And for the next research, I will focus to prolong the forecasting time, and I also will combine ANN model with other optimization algorithm to improve the forecasting results. And I would like to finish my presentation, and thank you for your time. And if you have any question, we can discuss together. Thank you. Thank you.
Thank you, Mr. Fong. It's quite interesting research here using ANN with back propagation algorithm for groundwater prediction. Maybe we need more research to get that up to the more the needed information. So it's quite exciting. So
thank you.
Sorry, the presenters. Our session time is limited until 10:35, so maybe we have to move on to our third speaker, Dr. Fong. Dr. Jung.
Yeah,
Dr. Jung.
yeah. Thank you.
Dr. Jung, please spend maybe 15 minutes, okay? 15.
Yeah. Thank you, Dr. Ko. And before my presentation, I just have one point to the group to discuss, to think. Maybe we don't have time to discuss, but to think that for the project from Smart Water project from Dr. Choice, we have meeting couple of days ago, and then they said that he interested in UA. He agreed this could be interest to them to do UANN for water supply and water treatment, especially water supply. So Dr. Phi and Hương think of just suggestion from the project. He would interested to use AI for water supply and water treatment. So from the excellent study on groundwater and also for landslide, maybe we need to think how to use it, how to adapt the model for water supply and water treatment that could be useful for the project, for the case study. Just keep in mind, and we will discuss in more detail later. And for now, I will share my presentation, and I will briefly with the talk, and then later one of my colleagues, Miss Ngọc, who actually is a former student from Dr. Choice, she will share about her recent app on draft monitoring using the satellite and cloud computing. But I would like to brief a little bit about what we recently on water model and data service for Vietnam and Mekong region. And actually, to do in our mind, we think that this could be helpful for using AI and ANN and other deep learning methods that we need big data. And how to get the big data, not only from the focus from institute data, but also from model and from other data platform like satellite or global model, or Sakai, very important for AI approach. So here we will share with you how we develop Sakai of big data for Vietnam and Mekong region, and we can see how we can use this for the region. So content will be briefly on what kind of data we have produced from forcing data, precipitation, temperature, historical and forecast data, and also the dam data, the curve, the topography of the dam, the reservoir, and regulation in and outflow, and also the model we have developed, and we can provide the data at the foundation for other research, and also groundwater monitoring and modeling, and then some brief on the application of how we have applied for different soil impact application like drought, flood, and water management in reservoir operation or urban planning and other climate change adaptation and water quality. So basically water is essential for life, and also the central for achieving a sustainable development goal. Then water very important for all the social economic activity, and also water is is also especially in Vietnam and Mekong and South Asia, and especially in Vietnam, you know that we heavily depend on the water from other countries, and rapid increase of the reservoir, and also water data sharing is problem, and data is a big problem. It's very scarce, so that is challenge to water management in Vietnam, and that's why we think of driven by impact. We think of should have as a innovation to provide a big data for the analysts for the water management. And the approach we do is we need a very invest on very intensive water monitoring network, and also the high computer facility and then operated in Nawabi. And the first one, the first product we produce is we produce the MERS data for whole Vietnam and whole Mekong region. You can see here we merge from InterSU, from satellite, from reanalysis, so we can provide a very complete and consistent data for whole Vietnam, and that can provide a very good quality data. Can you see my? It seems that my screen is lost. You can see my screen again.
Not yet.
Okay,
yeah, it's
now.
okay now.
Okay.
Available.
Yeah. So we the first service the first information we can service product we can provide to support for water management is to provide the consistent and high quality and high resolution rainfall data over Vietnam and Mekong region that merge from different sources, including InterSU and satellite and reanalysis data. So this is one of the data we can share. Would like to share, introduce to you. MERS precipitation data, and also temperature and other data for forcing for water model and water management. And you will see the graph here. We have a data after MERS. We have provide a better quality compared to other original individual data. And this is some evaluation for the water for the data quality control. And also we set up the national multi-basin model for the entire Vietnam, and including the Mekong and Red River Basin in upstream country. So now for any water study, we can provide the water essential variable data like stream flow, not only precipitation but also stream flow, evaporation, soil moisture, and groundwater for all 1,200 sub-basin for the whole Vietnam and Mekong region. So that could be very essential information and data we can provide. Not only the data but also impact scenario, impact assessment. We can use a model to assess this. And you may know that most challenge for the water management is the data on human intervention, especially reservoir operation. How we can get the data on the operation, how much water income and outcome and water level, operational rule, and such kind of information how we can get, especially in upstream outside of Vietnam. So that's why we developed the app, the algorithm to get the data, and here to show the data on the we get for each reservoir, and this is why we can get this kind of information into including water area, reservoir area, water level, storage, and also the bathymetry of the reservoir, so that it can be very fundamental, very essential input for water management and water modeling. And this is so that's just a quality control. We compare with the industry data to see how the model and algorithm can be, how good is this. And a little bit detail more about the calibration at the model calibration for the reservoir. And not only water quantity, but also water quality, like sediment and water quality. And the most not only set up the rainfall runoff, the catchment model, but also we link the hydraulic model with hydraulic model, so that we can address the water problem in the delta and coastal area across the countries. So here we use the MIC model to set up for own river network for whole country, and just slide show in the Red River and Mekong River. We can from this model we can address the other water problem in the delta, like erosion, soil intrusion, and also effect of the tidal effect on the water supply, water pumping in the delta. So this is to show you the model that we can use for different analysis and different in Vietnam. And not only surface water but also groundwater. We maintain the groundwater monitoring network of around 1,000 wells for almost 40 year long course over the nation. And also from this data we set up the model to provide the water forecast. The internet it seems lost again, and here I saw again why the internet is. So same for surface water we use for groundwater. Groundwater we set up for groundwater model, 3D water groundwater model, and also groundwater monitoring network for the almost the whole countries. So now any analysis on the groundwater level, groundwater solution, we can use this model to support for impact assessment, and also for groundwater forecasting. That can also have a alternative compared to, and later we can try to think how we can operationalize the ANN for groundwater forecasting in our national groundwater model like this. So the approach that Hương just present, I think is very helpful for our operational water management, groundwater management. And here is some application. Has some application we use from the model and from the data. We try to provide a complete picture of the water resource, water availability for the whole country. That is very updated and very information on water availability for the whole country for any river basin in Vietnam. So the first application we like water resource accounting to see how much water available for whole country for any sub basin and what is seasonality, drought and flood season, how water available for river basin. This is for application that important for water planning and water use. The second is that we see how the impact of dam, cascade dam to downstream and flow and sediment. For example, here we see from that Mekong and River and Mekong and Red River, we see every decade how the dam have impact on the chain of flow regime and sediment in the Mekong River basin. And another application that we provide the operational water forecast from 16 days to 6 months and even 12 months at own river basin in Vietnam. And this also for flood and drought warning from the forecast. We try to use operational, and for drought we try to have a drought monitoring. And the app is just launched recently, so let Ngọc Ruby will share with us on drought, and also the online monitoring of the sedimentation and flood. And also we this may be interested to you that now the Vietnam water law focus on nature-based water solution. And then some kind of green infrastructure and nature-based resolution like green roof, bioretention, swale, underground storage and infiltration system. We can see how much, how efficiency of this nature-based water solution that can help to reduce flood risk and drought risk. That is, we can provide some kind of impact assessment on beyond the model and data we provide. So we see the impact of climate change on the essential water variable like runoff, evaporation, soil moisture, and water quality. And then we try to support for water operational water management at the government water agency. Like here, we provide the water forecast, provide the water data, both for Vietnam user and also in Vietnamese, and also in English for regional user. So that is some very brief information of what we have provide for water, for modeling and data that can be provided and support for water management in Vietnam and Mekong region. And maybe now can you share a little bit more detail on the app we just recently launched on using the big data remote sensing by on cloud computing word engine for drought real-time monitoring. So now please.
Yes. Yes. Hi everyone. Can you hear me well? Hello.
Yes, you can hear.
Yes. So now I would like to share with you guys about an app I already did for. Let me share. Can you see it now?
Yes. Okay.
Yes. Firstly, I would like to introduce a little bit about me. Hi everyone. My name is Ngọc Nguyễn. I'm a PhD student at University of Houston. Today I would like to have a short introduction about the app which I built on Google Engine and satellite base for estimates automatics from Moody's drought and to estimate the drought for over Vietnam and the Mekong River basins. As you may see in the central, that is a map. I'm visualizing the drought index. The drought index I would like to show here, that is a NDDI. Instead of I only show about the vegetation index, I combine the normalized different water index and the normalized different vegetation index, and we call that is a normalized different drought index here. And I hope that this app can help the user easily to visual about the drought in Mekong River Basin with the left panel, as you may see here. You guys can easily define the year's range and this range, and otherwise you guys can define the correlate, or you can easily just click on the map, and then you guys can see the plot of drought index time series in the right panels, and under plots that is a drought classified with the higher NDDI values represent for higher drought intensity. Sorry, because my internet is not really good, so it takes time to generate the charts here. But otherwise, after we can generate the charts, and then we can download this as pictures or as a database. So I think now just 1 minute left. So that is all and short thing I want to show you guys for the app I would do for estimating the drought over the Vietnam and Mekong region. Yes, thank you.
Thank you, Ruby. Thank you all. And I think, hello, Dr. Ko and Dr. Phi, can you continue with the discussion and then also on this? Because I have another meeting, so I have to leave shortly. So actually,
yeah.
Basically the idea from the collaboration that for the smart water project is that we can use the idea is that Dr. Choi project will be interested to use AI for water supply and water treatment, so we can see how this approach can be used for that for that case study for Vietnam. So please discuss on this part, and I Dr. Phi, please together discuss with on that. I have to leave now. Thank you. And then we invite by chat. Thank you.
Thank you, Dr. Jung. I further discuss with Professor Choi regarding that one, but today we have quite excellent presentation, but I must apologize all of you because of our limited session time. Maybe we cannot continue for the discussion in depth, but I really appreciate excellent presentation by Dr. P and Ms. Fong and Dr. Jung. Also Ms. Ruby from the Houston, USA to join us. But we'll keep continue for this academic and communication, also try to secure joint research project so that we can continue to work together. So again, thanks all of the presenters this morning. So I'd like to conclude our session right now. Thank you.
Okay, thank you. So
Thank you, Dr. P.
Thank you. We'll
Yeah,
keep
thank you, sir.
we'll keep in touch.
Bye-bye,
Thank you,
Louis.
everyone. Thank you, Dr. P.
Yeah.
Thank you
Yeah.
so much.
And
Thank you.
Yes, sir.
Yeah.
good
Please
night.
home, come back
Yeah.
to Hanoi soon, okay? With
So
your doctoral
we'll
degree.
keep in
Bye-bye.
touch. Thank you.
Yeah.
Yeah.
Thank you.
Bye.
Bye.
Thank you. Yeah, so we'll
Nice
meet
day.
again.